All right, so today I'm going to be talking to you guys about the update I've done on my graphics engine, where in this case I have actually implemented a way to update position and rotation of specific bodies, both around a pinpoint and points outside of the body itself. So essentially in this program, what I'm going to be doing is I'm going to be talking about the texture and the texture, vertex, and fragment shader, as well as my texture class, where I actually import the texture so that the moon and the Earth have a proper texture on it. And then finally, I'm going to go into my scene where I kind of talk about where the updates and everything are taking place. So first things first, in our vertex shader, you're going to see that we're importing our, our vertex, our normal, and our texture coordinates. And then the thing that is going to be putting out all in vector 3s aside from the vector 2 is the vertex normal, the light direction, the vertex direction, and the UV chords as well. And essentially that's all going to kind of come into the shader class that we have talked about earlier, and that's going to allow us to have the proper light reflect off of the surface of the two planets. So essentially when you go into your main here, we're just going to set our UV to our texture coordinates, and then we're going to get our vertex normal by taking the normal matrix multiplied by our vector normal XYZ. And then what we're going to do is we're going to take our vertex position and take a vec3 of the view matrix multiplied by the model and the vertex as well. And then once we grab that, simply just take our light direction, we're going to normalize it, and that's going to kind of give us which way our light is heading now. And then once we get our vertex direction, it's actually going to be equal to the normalization of the vertex position. And then when we do the GL position, that's just us simply outputting a vector 4 in which we take the projection matrix, the view matrix, the model matrix, and the vertex into account. And then into our frag, not much has changed here. You can see that we have our spec light color. Essentially, I'm just going with a basic light gray to kind of give it a nice bright light. Then the float difference here, there's not going to be too much happening. That's at least relevant to the new code. And all of this kind of comes together essentially to give us that different refraction, reflection off of the planet. Not refraction, sorry. So first, when we look into our texture, what we're going to see is we have an empty constructor and destructor, and then we're going to have a bool for the load image. Oops, sorry. It's going to take a character for a character pointer for the file name. Essentially, what that's going to be used for, as I will show shortly after, is it's just going to be like, did this load properly, yes or no, and then it'll spit something out if everything fails. And then our inline get texture, of course, so that we can actually apply the texture to the proper texture map in the mesh. And then when we go into our texture.cpp, of course, since we included everything in the header file, we don't need to do that anymore. So the main thing here is just the texture class. And essentially what we're doing is we're taking the GL generate textures of one and then a reference to the texture ID, and then we're going to bind it with GL texture 2D and then texture ID because it's just a simple 2D texture image instead of a 3D texture image. Then we're going to take the surface, create a pointer to it, and then we're going to use the file name that we had previously taken from our Boolean, and we're going to attach it to the pointer of that texture surface, so kind of allowing us to grab that surface whenever we need to without having to bring the whole object as. Um, and then right here at the end, we're just simply wrapping everything as well as giving it a little bit of a filter to kind of clean everything up as it renders. And then moving on to our scene, nothing new as compared to the skull project, aside from the fact that we're going to have a few more pointers because there's going to be more objects in the scene now. Of course, we still have our pointer for the camera, we have our pointer for the ball, and we have our pointer for the earth, as well as our vector for the light source. And then, of course, we just have all of our overrides. Nothing new here as compared to scene 0. And, of course, first thing we're going to do is we're going to create our camera. That way we're going to actually be able to visually represent the scene. We're going to load in our sphere object um, initially, and then obviously checking if it worked or not. Then it will create an error message if it had failed. We're going to create our mesh pointer, and we're going to bind the triangles, the vertices, the normal, and the UV chords all to the mesh of the object here. And then we're going to create this. We're going to do the same with the texture frag and vert GLSL to actually apply the shader properties to it. And then once that is done, we can properly apply the moon texture to it, which is just a simple moon JPEG. And we're going to do the exact same thing for our Earth texture pointer, which is going to use a lot of the same code because it's going to create a very similar body just in a larger size. And it's going to attach the Earth to it as well. And that you can all see right here where ball and Earth are both being created. Ball was just what the early build for the moon was called, and I just never got around to renaming it, though the ball object is actually going to be your moon. And then of course you see me creating our light source where it's just back a little bit and then it's down a little bit, so it's going to be able to kind of like shine in, similar to how it did on the skull. And then of course on destroy, we're just deleting all the pointers to try to get rid of any memory leaks. And then in our update, this is where this actual rotation is going to be taking place. So if you can see in here, we're going to have our static float of a rotate, and then we're going to have rotate slowly increase because it's going to actually render it at a specific angle instead of use that angle to rotate it. So essentially when we increase this value, as it rotates, it's going to be rendering this object at a different angle of angle of like representation every time, giving it the appearance that it's rotating when really it's just physically moving from update to update. And then on top of that, what we're going to do is we're also going to be setting the translate out so that the moon here is going to be rotating around the Earth instead of around its own central axis. And once we do that, we're going to update it with respect to delta time, and we're going to do a similar set of equations for Earth, though it's only going to be rotating around its central point at about a 13-degree angle. So essentially what we're going to be doing there is very similar to what we did with the moon. Mine is the translate, as we actually just want it to stay in the exact same space. Um, and finally, when we go into our render, it's going to be the exact same as we had previously talked about in the skull representation, so I can just go ahead and show you guys how the code works. So as we can see here, we do have the Earth and the Moon rotating respective to one another. The Moon's a little hard to see in this dark environment, but as you can see, it gets closer. That light really hits it, and you can really see that shine off of the texture of the planet as well as it's rotating. So thank you guys for tuning in. I'll be back with further updates.